Hi, I'm Girish Bhatt with Sumo Logic. In the next session, Jeff Rowe, who's a cybersecurity architect at UC Davis, will walk us through how he and his team are using a security orchestration automation response tool to detect threats faster and improve the overall efficiency of the UC Davis SOC. Jeff, the session is all yours.
So I'm Jeff Rowe, and I am a security architect at UC Davis, and I'm going to be talking today about how we use a Sumo Logic SOAR at UC Davis to do a lot of automation and threat investigations. So as I said, I'm Jeff. I've had many years experience in cybersecurity. Previous to this, I was a research scientist in the computer science department, and then I changed to IT operations about 5 or 6 years ago. So I have a wide variety of sort of security backgrounds and expertise, and I only started doing operations in the last 5 years, and I really enjoy it, and it's super fun. And so a lot of the stuff I talk about is the things that we do here at UC Davis. UC Davis is a large Research One institution, and that introduces its own sort of challenges. And I think I'll talk about that, and I'll talk about how we were really able to take our operations to the next level by going down the SOAR route. And I think that the Sumo Logic SOAR platform was really instrumental, and it fits the university perfectly. And so we'll talk about that, and I'll give a very brief demo and then talk about the next steps that we're going to take here to sort of mature our practice. So anybody who's ever worked at a university will know this, but it's a large organization. First of all, that's not super unusual, but we have maybe 5,000 servers, 50, 60K client endpoints at any given day, and that they rotate. So we'll have a different set tomorrow, but on any sort of given day, 50,000 laptops, workstations, whatever. And then we have about 170,000 users in our identity management system. So that's large, and then we have to deal with that. It's no surprise that we have a lot of high value research here at UC Davis, and that's can be quite the target for our attackers. But a thing that a lot of people don't realize, and it's different than a typical enterprise, is that we have a huge variety of other things we have to deal with. Student health center, we have a clinic with patients, and so if you know about HIPAA, then we're subject to that. We have about 120 credit card merchants on campus. They sell tickets to games and sweatshirts, and you can buy genome services, whatever. A huge number of those on campus, and you're subject to PCI in that case. We have a lot of DoD funded research. It's a little bit surprising, but we do. The big wild card is that people live on campus in our network, so they have an apartment, and they like to watch Netflix and play games. So you can't, that's their house. They can do what they want. We can't have a policy that sort of forbids that, and so that can be a challenge. And then we have a huge variety of industrial control system like services. We have a whole entire PG&E substation on campus that we operate, and we have wastewater, chilled water plants, and automated agriculture. It's just a huge number of control systems on campus that we have to monitor and maintain. And we have police, fire, all kinds of stuff. We have an airport. And as challenging as that is, the real hard part is that we have open access policies, so we can't just deny everything and only allow stuff through that we want. We have to be fairly liberal. People want to do their research. They don't want to have to jump through a bunch of hoops. So that can be very challenging. The second thing is we have a federated governance model where I work for central IT. We have a fairly small team, and we work with the campus departments, which sometimes even have a team bigger than ours, to get the security job done. And so we have to take care of their needs, provide them with sort of role-based access control. So not everybody gets access to everything. So here's the security operations that UC Davis at the sort of 30,000 foot level. We have, I've sort of arbitrarily decided these, what these domains are. You could organize it differently, but there's these main categories that are filled with our, core sort of technology portfolio systems: intrusion detection, prevention, firewalls for networking. And we have, tons of software logs, syslog and file integrity monitoring, all kinds of systems like that. And then we also have the authentication systems that produce information as to what our users' behavior is like. And so the real challenge is to manage all this information in a unified way and not treat intrusion detection differently than user account security and software security. So all of these systems we have generate about 10,000 logs per second, and that grows all the time because I always want more visibility. So the real SOC workflow is all about managing this information flow. How do we want to be able to take the vulnerabilities, for example, and connect up intrusion detection with software security flaws. And so we can do that by having these sort of intermediary technologies in place. We organize our information flow roughly by these three categories. We have events, and this is the fire hose. This is the 10,000 units per second. We have what we call configuration, and that is, relatively static. What department is this in? Is it critical? What kind of service does it provide? And then we have what we call directives, which is, okay, so you've used the events to find out something's wrong. You take the configuration and see that it's something serious. Now what do you do about it? And you can change some firewall rules perhaps, or you can even something like send an email, open a ticket to get this taken care of. And so the three tasks are to do the investigation, that's related to events, and conduct an appraisal that is related to the configuration, right? What is this, something serious or not? And then to respond and take some action, and then go around and around. So this continues until you're satisfied that you've done enough, right? Sometimes the response is somebody tells you, oh, this is not what you think it is, and then we'll do a different kind of investigation. Keep going until we're done. And so, that's roughly the information flow coupled with the workflow model you see, Davis. The first step is the events, right? We have this huge number of events. How do we actually unify that into one system instead of having to go around and collect logs from everywhere? And we have an elastic logging system. We have a ton of logs in our data center. These are central IT systems that do authentication, email, assigning network addresses and things like that. We get tons of logs from them. We have in our own SOC operations center, we have all the security tools running. We collect all those logs. We have APIs for vendors. We get all those things come into our logging cluster. And so right now our logging cluster can handle about 800 gigabytes per day on average, but peak can go up to a terabyte a day. So we have this and it runs and it works well. And so this is a big advantage for us because now we have a lot of the information in one place. We don't have to integrate a gazillion different systems. The real hard part for us, and the thing that causes us the most grief, is the workflow. When you have to deal with multiple portals. So, we get an intrusion detection system or an IPS, you log into their portal and you do some kind of, list, you go through the alerts that they've listed and see what they have to say. But then you've got to correlate that with other things on campus. What does that look like in the firewall? So you copy this and paste it into the other portal. And what do you have, 10 different portals open at once on the screen, and it just takes forever. And that really is painful and time consuming. You work through some playbook manually using manual logins to multiple portals. So I think about maybe a couple of years ago, we decided that, we're going to try to make our lives easier by scripting. Other universities and other organizations will have developed a software system, sort of a monolithic one system to rule everything, and then develop a bunch of plugins for the portfolio, the technology portfolio. We took the more lightweight approach. We have standalone Python scripts that each one covers a single sort of technology in our portfolio, and then we use the command line or a couple of other extra sort of workflow tools to actually do the work instead of logging into the portal. And that actually sped things up a lot. And it leveraged one of our strengths, which is we have students at UC Davis that we hire. So our SOC professional SOC team is fairly small, but we have a small army of students who are actually pretty good Python programmers. They're extremely green as far as security goes, and they don't know all the details of doing security investigations, but they do enjoy programming in Python, and they know how to do it well. And so we have them develop this war chest of scripts. Not a program. It's not a software engineered, single system. It's mostly a bunch of scripts that integrate with our assets. So we thought, well, now that we have this sort of scripting war chest, why are we even cutting and pasting between scripts and typing in things at the command line? Let's just automate everything. Let's just try to do as much of the stuff that we're doing now as we can automatically, and then we can just leave this whole idea of a security SIEM in the rearview mirror and jump straight into the SOAR. We had a SIEM for a long time. It was a big one by a well-known vendor. It sucked and it was hard to use and it was difficult to maintain. So we thought, well, let's leapfrog the whole SIEM concept and go into SOAR, and then we'll just use the raw logging system when we want to look at the details. So we'll automate everything. We'll look at APIs instead of portals and dashboards, and we'll look at standalone scripting instead of maintaining a large-scale system that requires software engineering. And then maybe we can even go use a little bit of custom AI analytics to assist in our workflows. So this is a picture of the 15 minutes of border security monitoring. So 15 minutes, 5 minutes. In 5 minutes, we get 500,000 network connections across the border. So that's a decent amount of data. We also have alerts. And so here is, I took this snapshot at around 11 in the morning. And so by 11 o'clock, we had already had 4,000 alerts from our malware detector. We had detected 10,000 malicious signatures, and we had 250,000 events from our threat intel corpus. And so, that's a lot of alerts. So, how do we manage all these? And, they're not just idle either. They come from all the bad places in the world, Bulgaria, Russia. Russia's pretty much always lit up here. And so this is not something we can just ignore, but we want to have a way to automatically work through these. And so we developed our own sort of alert automation investigation. So what we do is we come up with a package. And so the alert index is large, but it's not as big as the raw events. And so we take a single alert, and then we look up in the raw event fire hose, essentially, all of the events that we think correlate with the original alert. And it's fairly simple-minded, simple matching and aggregation. And then we do some filtering, and then we package the whole thing as an investigation. And when we're done, we have a fairly small number of investigations that we hope to be able to deal with. So here is what it looks like in our Elastic cluster. We have multiple alerts here. Following that sort of path, we thought, let's just have a platform that's dedicated to this. We'll have a next generation orchestration and automation platform. We call it, the project is called UCD SOAR, and we'll do all of that stuff automatically if we can, and not even have to go into the dashboard unless it's absolutely necessary. And so we went shopping. We looked at a variety of SOAR vendors. This was about 1.5 years, 2 years ago. We got demos from a lot of major players. After we got the demos, we did focused proof of concept with 3 vendors. DF Labs was one of them. It's now Sumo Logic. And we had to make a decision. And I want to say that it's always tempting to just choose the one with the most features, right? Oh, it's got all these cool things. Let's just get that. Let's pick that one, and then figure out how to use it later. Well, we've done that before, and we end up not actually using most of the features that we paid for. And so we learned that at the university we got to do some kind of impedance matching when we decide upon a specific product or vendor. And the Sumo Logic SOAR was absolutely perfect as far as the student developers go. So we don't have to program a big system. That had already been done for us in the platform. We already had a bunch of Python scripts that our students had developed for us, and so it worked. It just sort of seamlessly worked with the existing architecture of the Sumo Logic SOAR. And almost all of our information was already in an Elastic cluster, so we didn't have to worry about coming up with a ton of custom sort of integrations. And we could run it on-prem. That was a big boost for us also. The price was very attractive. So I'm going to give a very quick demo of what this looks like. And this is an example of investigating alert, like I showed before. It's built upon our investigation packaging underneath, but instead of going through the full sort of dashboard with all the graphs and have to understand it at that level, I'll try to show a little bit here about how this works. Get the investigation information, all the IP addresses, all the relevant information from the alert. We look up all of the sort of configuration information from the online data, from the campus database. We get the reputation of the attacker from the web. Did any user log in from here? We can get all the user behavior context from that. And then we have a single sort of task that we create. That is what the analyst has to do. The analyst doesn't have to worry about doing any of this other stuff anymore, in addition to looking at the investigation. So if you take a look at the task, you see it's fairly simple. Investigate the alert, and then here all the information that we collected is presented in this sort of single simple list of values. And you can see immediately that this is okay, it's something serious. We could use that link to look at the full dashboard if you want, but since it was somebody with, I think it was a fake update alert, it's something that we don't typically think is significant. We'll call it an insignificant thing, assign it low priority, and close it, and then we're done. That's it. All that other work has been done for us automatically. And in addition, once we say that it's low priority and insignificant, this automatically closes the task, and we can move on. If we didn't decide that if we decided it was something important and worth looking at, then it would automatically send an email to the person that we looked up before, telling them to, here's the information we have on you, do the further investigation. So let me talk a little bit about our configuration. We use, since we have most of our stuff in Elastic already, we just used the existing Elastic integration from Sumo Logic, from the SOAR that they have. So we didn't even have to build that from scratch. It was already configured, and all we had to do was change it slightly. So we created our own daemon to get the data, get the incident data, and then a quick example here of what this looks like. It's just Python, and it's just the Python that we've had for a while. We just take what we have already, create our own action, and then do a slight amount of debugging to get it to work in the overall SOAR, Sumo Logic SOAR platform, and it works. We don't have to do a lot of extra work. We didn't have to spend a lot of time doing sort of integration with third-party products. So that is basically our story in a nutshell. I think automation is helping UC Davis. cope with a huge investigation workflow. We can dispense with tons and tons of these, sort of alerts in a short time period. We're trying to move this way for all of our workflows. We've already integrated user account behavioral investigations. We've integrated we do vulnerability scanning. So any sort of high risk vulnerability, we automatically dispense with those and do the mitigation request for that. And we also do endpoint protection alerting. So, those are the 4 big ones that we have at UC Davis, and those have already been integrated. The other thing is, university educates students. The students like to do the work. It's not something, they hate to click on tickets and just, follow scripts and stuff like that. If that's no fun for anybody. And they love to do the configuration of the automation. And so that helps them a lot. And once they graduate and they have some experience in the security realm and they have some experience in Python scripting and Elasticsearch, then man, they get snapped up right after graduation. So that's a big win for everyone. I think the next thing we really would like to do is integrate more automatic responses into SOAR, including, blocking rules at the border, perhaps, and quarantine of devices that are, have high critical vulnerabilities. And then the big desire is to have compliance playbooks. So, we wouldn't have to worry about whether we were doing the right HIPAA thing or the PCI thing. We'd have a playbook in place to guarantee that we followed all the right procedures for those types of problems. So in a nutshell, I think that's what we're doing. I think we're really happy. And the fact that we chose this particular sort of a platform for doing our SOAR really boosts us in the university's mission overall. So,
Jeff, I have a question for you. First of all, it was a great presentation. Thank you very much, Jeff. Very informative. The first question I have is around how many people do you have that are using SOAR today? And how many people are managing? How many people does it take to manage or keep it up and running for you?
Well, so I'll answer by saying that, when we started from scratch, I think we had a half-time senior FTE working on it to get it configured and working at first. And it took us about 6 months before we were in a position to actually use it in sort of production workflows. Now that it's working, then of course it takes much less. I think we probably maybe 10% of a senior FTE and maybe a quarter of a junior. But it doesn't really take that much to keep it going. We just want to continuously improve and add more integrations. As far as people using it go, I think one of the big advantages to this particular platform is that it gives us full role-based access control and groupings. And so if somebody in the College of Engineering, say, wants to look at the College of Engineering information and do their own sort of investigations and remediations, we can let them do that. There's no spillover between what they see and what another department sees, which is a huge issue here at UC Davis. People don't want to have their, they want to have access to what they control, and nobody else should have access to that. And so we can do that perfectly with the built-in role-based access control. So I think we have a total of 18 sort of high-level users that use it like that. Not just our office, it's other people on campus.
Cool. Thank you, Jeff. I've really one more question for you. So the way in which your SOC currently operates, it seems that you're using the SOAR as your dashboard. You're using the equivalent of SIM as alerting, correlation, and alerting capability, but then SOAR is your dashboard or view into the SOC. Is that what you have today, or is that the direction you're going? I just wanted to make sure.
Well, I think we use it as a more like a workflow manager, and that actually helps us avoid using the dashboard. So you just cannot possibly do a full dashboard investigation of 100 alerts a day. You're just never going to do that. And so what the big advantage to the SOAR is we can go through the list and see immediately, we collected all this information from the internet, all this other stuff automatically, which would take us 1,000 years otherwise. And that lets us just immediately dismiss 90% of the stuff and leaves us with 10 left over. And then, yeah, you do want to go into the dashboard then. You do need those extra details and be able to do the full analytics, and see all the other stuff. But by the time we've done that, we've already collected all the information we need, and we've already dispensed with a bunch of other things that we're not necessarily concerned with.
Cool. Thank you.
That's our sort of working model. We do the deep dive with the dashboard when we need to, but the SOAR just like illuminates the vast majority of what we have to worry about.
Thank you. When you were saying that, one last question came up in my mind, and this is again, I'm putting the lens of a research university or a higher institution, right? So how many? This is something that often people grapple with. I've in my previous experience with SOAR tools, how many playbooks or equivalent have you operationalized at UC Davis?
I would say we probably have 8, but some of those are pretty big. So rather than creating a bunch of smaller ones, I think we gravitated more towards one playbook for one very large category of the work that we have to do. So I think vulnerability remediation is one of those fairly large ones. There's medium, highs, criticals, lows. I mean, all kinds of things you have to worry about, and each one of those has a different sort of workflow associated with them. So we have like really big playbooks rather than a bunch of small ones. Instead of 5 small ones, we have one big one.
Yeah, that's spot on with what I've heard before as well, Jeff. Even some of the larger enterprises outside who come from a commercial perspective, they have less than 10 playbooks that they've operationalized. They may list more but it's really the common attacks and vulnerabilities. It's fairly a shorter list. Within that, as you said, there are different nuances and streams.
I think we're looking at more, and I think the most promising ones that we're working on now are the ones that get generated from a web reporting page that's built in. That this particular platform has a way for you to put up a reporting web page for your users, and then they go in and categorize the things that they think are important, and then that just kicks off an incident and a workflow, which we didn't have that capability at all. So it sort of kills 2 birds with 1 stone that way.
Again, that is fantastic. Again, thank you, Jeff, on behalf of Sumo Logic and our partners. That was a very insightful session, and looking forward to working with you more in the near future.
My pleasure.